All right, here we go. This is question number 5 from the 2018 BC exam. This is the question you would have worked on if you took the exam in May 2018. Because this is question 5, that means that you do not get to use your calculator. Now, as soon as I looked at this question, I said, oh, we're doing a polar question. And polar questions show up very regularly on the Calculus BC exam. If it's not a polar question that's going to be on your exam, it's going to be a parametric motion question that's going to be on your exam. But you need to be ready for both. So here we go. The graphs of the polar curve r equals 4 and r equals 3 plus 2 cosine theta are shown in the figure above. The curves intersect at theta equals pi over 3 and theta equals 5 pi over 3. So now they didn't label the graphs here, but this first one that I see on the left is a circle, so this is going to be the graph of r equals 4. And then we've got r equals 3 plus 2 cosine theta must be the other one. They're being kind in this question, and they're telling you that at theta equals pi over 3, and down here at theta equals 5 pi over 3, the two curves intersect. And remember, when we work in polar, we think about the angle. We're starting here at 0, and we're thinking about the angle as we increase. And so this angle right here is pi over 3. And if I were to keep going all the way around the circle, that's when I'm going to get the next intersection point. And there's this ray starting at the origin, or the pole, at theta equals 5 pi over 3 that's going to correspond to those two curves intersecting. And I usually add that information on there because it's usually going to be helpful. I want to make sure that I understand how the graphs are working in polar. Okay. In part A, we're asked, or we're told, let R be the shaded region that is inside the graph of r equals 4 and outside the graph of r equals 3 plus 2 cosine theta. So r equals 4 is this curve over here. Even if you didn't know it, they've told you that. And r equals 3 plus 2 cosine theta is this guy in here. Write an expression involving an integral for the area of r. Now, in polar, the area formula works a little bit differently, and you just need to have this memorized at this point. It's 1/2 the integral of the radius squared, integrating with respect to theta, from your first angle to your second angle. Now, let's see what's going on over here. If I look at r equals 4 as the outer curve, which it is, if I integrate from pi over 3 all the way to 5 pi over 3, the problem is you're going to get all of this area that I'm shading in right now, which is too much area. You don't want the white portion. So what I'm going to do is I'm going to say that my area is 1/2 the integral from pi over 3 to 5 pi over 3 of 4 squared, and I'm going to integrate with respect to theta. Oh, let me scoot that up a little bit. Sorry. But now I've got to determine the area of the white region. I have to subtract that off. To do that, I'm going to say minus 1/2 the integral, again from pi over 3 to 5 pi over 3, and I need the radius for the inside curve, which is 3 plus 2 cosine theta, and all that is squared, and I'm going to integrate with respect to theta. In this question, all they wanted me to do was the setup. They have no interest in my evaluating this integral. That normally goes beyond what they're going to assess on the Calculus BC exam. And this is actually worth 3 points. They offer 1 point if you get the constant, that's the 1/2, and the limits of integration correct. Now, because of the way I've done this, I'd have to get it right in both integrals to get 1 point. And then they offer 2 points for the integrand. On the College Board scoring rubric, they decided to use 1 integral instead of 2, and that's okay. Both integrals are multiplied by 1/2. Both integrals are being evaluated at pi over 3 and 5 pi over 3. So I could combine these into one integral, but I saw it as two different ones. So I would say 1 point for the 4 squared with respect to theta, 1 point for the 3 plus 2 cosine theta squared with respect to theta, for a grand total of 3 points. This is a pretty standard question for for a polar question. You've just picked up 3 points. We did that relatively quickly. Let's see how the rest of this goes. In part B, we're asked to find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2. All right. Well, slope of tangent at theta equals pi over 2. We know from a whole lot of calculus that we're going to find the slope of the tangent line by dy dx. That's our derivative. The challenge, though, is we are not working in rectangular. The way that you evaluate dy dx, the slope of the tangent line in polar, is you actually find the derivative of y with respect to theta, and you divide it by the derivative of x with respect to theta. And you might say, okay, but what's x and what's y? In order to do this, you're going to have to take your formula, your polar curve formula, which is the radius in terms of the angle, and you're going to use your conversion formulas. X is equal to r times cosine of theta, and y is equal to r times sine of theta. And you're going to take the derivative of both of these with respect to theta. Now, everything that I've just written in purple, these are things that you just need to know coming into a polar curve kind of question. If you don't know them, I'd make them into a flashcard. I'd do whatever you need to do to make that happen. So let's do it. Now let me scoot this up. All right, we know that our radius equation is 3 plus 2 cosine theta. So x is 3 plus 2 cosine theta times cosine of theta. And y is 3 plus 2 cosine of theta times sine of theta. Dx d theta. You're going to take the derivative of the x coordinate with respect to theta. I see a product rule, so we're going to take the derivative of the first expression, negative 2 sine theta, leave the second one alone, plus leave the first expression alone, times the derivative of the second. I'm going to evaluate dx d theta at pi over 2. Well, negative 2 sine pi over 2 times cosine of pi over 2 plus 3 plus 2 cosine of pi over 2 times negative sine of pi over 2. I'm going to go over here. I'm going to find the derivative of y with respect to theta. Again, product rule. Negative 2 sine theta times sine theta plus 3 plus 2 cosine theta times cosine theta. Dy d theta at pi over 2 is negative 2 sine pi over 2 times sine pi over 2 plus 3 plus 2 cosine pi over 2 times cosine of pi over 2. And I know that if you've been watching these videos, you've heard me say again and again and again, don't simplify, don't simplify, don't simplify. And that is correct, and that's still good advice. You want to keep in mind we're not done yet, because what you need is dy dx at theta equals pi over 2. So you're going to take this whole expression, you're going to divide it by this expression over here. So let's write it, negative 2 sine pi over 2 times sine pi over 2 plus 3 plus 2 cosine pi over 2 times cosine pi over 2. All that divided by my dx d theta, negative 2 sine pi over 2 cosine pi over 2 plus 3 plus 2 cosine pi over 2 times negative sine of pi over 2. That's it. That's your final answer. There's no need to simplify any further. For those of you that want to do the simplification, hey, feel free, but be careful. The sine of pi over 2 is 1. Sine pi over 2 is 1. Cosine of pi over 2, well, that's 0, 0, 0, 0. Sine pi over 2 is 1. Negative sine pi over 2 is negative 1. When I pull all this together, I've got negative 2 times 1 times 1, negative 2, plus 3. Let's see, this is 3 plus 0, so that's 3 times 0, that's just 0. Negative 2 times 1 is negative 2, but I'm multiplying by 0. Plus 3 plus 2 times 0, that's 3. Times negative 1 is negative 3, so 2/3. If you're really good with the trigonometry, if you know that you are just rocking all that, feel free to simplify, or feel free to simplify back here, but it's not necessary. This answer that I had before doing the evaluation is 100% correct. For a student in Calculus BC, I would expect that you're able to get down to 2/3, but keep in mind it's not necessary, and the time that you're spending there is potentially time that you are throwing away. So be careful. All right, let's look at the scoring rubric. According to the College Board scoring rubric, if you came up with the expression for dx d theta correct, or the expression for dy d theta correct, you got 1 point. That's sort of an interesting way for them to approach this. You're getting sort of an opportunity. As long as you get one of these right, you get a point. For knowing that dy dx is dy d theta over dx d theta, that is going to award you another point. And then for getting here to the unsimplified answer, or to the 2/3, gets you that final point for a grand total of 3 points. Not bad. We've got one part left to go. Let's see how we're doing. Okay. In part C, we're told that a particle moves along the portion of the curve r equals 3 plus 2 cosine theta for 0 less than theta less than pi over 2. The particle moves in such a way that the distance between the particle and the origin increases at a rate of 3 units per second. Okay. Find the rate at which the angle theta changes with respect to time at the instant when the position of the particle corresponds to theta equals pi over 3. Indicate units of measure. All right, let's read through this again. A particle moves along the portion of the curve r equals 3 plus 2 cosine theta from 0 to pi over 2. Okay, 3 plus 2 cosine of theta, that's this guy here. And we've got a particle moving along from theta equals 0 right here to theta equals pi over 2 right here. Your particle is moving this way. Okay? The particle moves in such a way that the distance between the particle and the origin, so here's the origin, here's the particle at some time, let's call that r, that or increases, or yeah, I think we can call it r, increases at a constant rate of 3 units per second. So for the particle, dr d theta is 3 units per second. Yeah. I want to find the rate at which angle theta changes with respect to time at the instant when the position of the particle corresponds to theta equals pi over 3. I'm going to read that one more time. The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Ah, that's where I blew it. I knew something was wrong. Sorry about that. Okay. The distance between the particle and the origin increases at a constant rate of 3 units per second. My mistake earlier is I said dr d theta equals 3 units per second. But that's not what the problem says. It says that the distance between the particle and the origin increases at a constant rate of 3 units per second. But if I look at the units here, I've got units per second. I'm not looking at how the radius changes with respect to theta. I'm looking at how the radius changes with respect to time. So 3 units per second. What I want is dr dt. I know that my radius is 3 plus 2 cosine of theta. I want dr dt, the derivative of the radius with respect to time, but what I have is the radius in terms of theta. So if I'm going to find dr dt, what we're going to have to do is related rates. The derivative of 3, well, that's just 0, plus the derivative of 2 times cosine theta is 2 times negative sine theta, but I'm taking the derivative with respect to time, so what I need here is d theta dt. Yep. So let me clean this up. Dr dt equals negative 2 sine theta times d theta dt. That's the relationship that I needed. I want to know what the value of, let's see, what was the question again? Find the rate at which the angle theta changes with respect to time at the instant when the position of the particle is pi over 3. Theta equals pi over 3. So what I want is d theta dt when theta equals pi over 3. Well, I'm just going to evaluate at theta equals pi over 3. Dr dt is negative 2 times the sine of pi over 3 times d theta dt. They told us earlier in the problem that the radius changes with respect to time at a constant rate of 3 units per second. So that means that this dr dt, 3, equals negative 2 times the sine of pi over 3 times d theta dt when theta equals pi over 3. This is the expression that I'm looking for. So all I need to do is divide both sides by the negative 2 sine pi over 3. So 3 divided by negative 2 sine pi over 3 is equal to d theta dt when theta equals pi over 3. Now, what are the units going to be? What are the units for theta, your angle? That has to be radians. The units for time, we were told that the radius changes at a rate of 3 units per second, so we're measuring time in seconds. If you want to simplify, that's fine. Sine of pi over 3 is, what is that? The square root of 3 over 2. Negative 2 times square root of 3 over 2 is going to be negative square root of 3. If you want to go further with the simplification, feel free, but it's not necessary. You could multiply by square root of 3 over square root of 3. Ultimately, what you're going to get is negative square root of 3 radians per second is your value of d theta dt when theta equals pi over 3. All right, how did they award points? They awarded 1 point for coming up with the value of your derivative, the dr dt equals negative 2 sine theta times d theta dt. They then awarded 1 point for coming up with the answer, including the units. And the way I approach this problem is a little bit differently than the way they approached the problem. What they said is they awarded a point when you get to d theta dt is equal to dr dt times 1 over negative 2 sine theta. What this means to me is they awarded the point when you took this initial relationship with the theta, just the general theta, not pi over 3, and you divided both sides by negative 2 sine theta. What I decided to do is I kept the equation in this form, then I evaluated at pi over 3 and replaced the 3 over here, and then I started solving. So what I did kind of combined this point here and this point here. I'm sure the College Board had figured out because I think this is a pretty standard approach, that they would have awarded a point somewhere in here. I'm not sure where it is, but in total this question would be worth 3 points. Okay, that's it.